Well, hi, McNamara from systemeducation.com, and we're following up on the overview presentation of how would we use Bucky Fuller's ideas to connect us up to biomimicry. We know that he was inspired by nature. How can we take some of those generalized principles and both understand Fuller's ideas, theories, and explanations better, and give us another more general way of looking at nature. So, in the other lecture, you saw a mind map, and this has been added to. And so then precession is this idea that in classical physics, I guess I'll say, there's a saying that for every action, there's an equal and opposite reaction. And as Bucky pointed out, that's sort of not exactly true. So let's just say that's our action and our reaction. They don't cancel each other out because it would be like energy being destroyed, right? So they can't. And so therefore, there's some excess energy that comes off to the side, which is called precession. And that, Bucky said, is how everything couples together. Every system is polyhedral, if you will, which means it's closed in at least 3 space. And as Bucky put it, it has what he called leaky corners. So if we look at this tetrahedron, which looks, of course, perfectly symmetrical, and of course, nothing in nature, well, very few things really are, we would see that these edges or relations or forces, if you will, they're the verbs, if you will, and they interact at the nodes, but they don't cancel out, remember? In some cases, most of it might go back internally to the system. That could happen, but we know that there are no closed systems in the universe. So by and large, what that means is there's something coming off the corners, and Bucky called this leaky corners. All the corners are leaky, and that's how systems interconnect. So that excess, that extra, could be what he called, I think, energy, material, or information. And it's really how systems couple together. And so if you remember other things that Bucky talked about, if you have a single point of connection between one system and another, they can freely rotate, if you will. And this is more like the atoms of gas. Okay, they're not coupled together whatsoever. If you have 2 points of connection, it's a little bit more like a hinge. And Bucky said this is more like a liquid now, where you can move, but you're still, connected together as a liquid. And then finally, if you have that last point of interconnection, then what's happening is you actually get the two systems more or less become one system. Now, these points of interconnection, remember, are these edges, which are now or are verbs or flows or forces, and by sort of definition, they only go one way. So that when 2 systems interconnect, it turns out there's something going one way and something coming back the other way. And you might think of this in terms of how you work. Like if this is the work system over here, and you're connected up to it, and actually it won't come to a point, it'll come to 2 different points, won't it? So here's the work system and here is you. Sorry, but you'll get the idea. So let's get this together now. So these, 2 very simple systems, right? And so then there's these 2 points of interconnection, so they're coupled systems. Well, one is a flow going in. Let's just say this is work. What do you contribute to work? And of course, it's many things, but you might create something, or you might integrate things, or you communicate, etc. And then what's coming back? Well, there's validation, there's hopefully wages, maybe benefits. So there's always these 2 things. Okay, well, that's how nature works, right? If you look at the Life's Principles from Biomimicry Institute, or Life's Patterns from Hoagland and Dobson's, where how nature works, you'll see that one of them is that nature creates conditions conducive to life. And what that means is that these couplings and interactions, if you will, benefit the other and actually benefit the larger system, because there's many. It's never as simple as I just put it there with 2 of them. So then, Bucky's famous example of precession, which is what we're talking about. Remember, we started with precession. Turned out to be that the generalized idea there is these leaky corners, right, extra energy, and that really the interesting cases are system coupling. So his famous example is the bee going into the flower. And so what happens there is the bee is going after pollen or nectar. It picks up some extra pollen. When it gets to the next flower, it basically transfers that pollen. It pollinates the next flower. It's a benefit to both of them. All right. So this kind of systems coupling, it didn't just happen, did it? It's what we call coevolution. So what are the attributes? These two systems are adapted to each other. The pollinator can accept the material. The flower has the excess capacity. On the other side, the flower can accept the pollen coming in. So there's a lot of little things here, right? And there's a lot of complexity, I guess, or detail, if you will. I mean, the shape such that the body of the pollinator fits, and the colors of the flower to attract certain pollinators and that sort of thing. Other examples are system coupling, which are not exactly the same. They're slightly different. So if birds eat a fruit like a cherry and then fly off, they'll deposit it, right, in a lump of fertilizer. That's a pretty cool thing. So then the birds eat the fruit, and that's a benefit, and then the plant gets the seed, or the tree probably gets the seed dispersed in a way that will make it more likely to succeed. One that has less sort of direct system-to-system coupling is the example of earthworms aerating the soil. So the earthworm is just doing what it's doing, right? It's chewing up soil and et cetera, et cetera. But the fact that the soil is aerated benefits many microorganisms in the soil, and of course you, if you're the kind of person who grows stuff. And so those are some attributes of that. Now, in general, this sort of thing that Bucky described, of which precession is sort of the key thing is this precession, but it's got to be these coupled precessions. Remember, at least two and maybe more. It's really what they call symbiosis. And symbiosis has a couple different things. There's commensalism, where it's not, where one species benefits a lot more than the other, and the other one doesn't get harmed too much by that sort of thing. And then there's mutualism, which pollination is an example of mutualism. And another one is propagation. Okay, that's so both of them benefit, if you will. And the mycorrhizal fungi, if you think about it, what the fungi are doing are they sort of build towards the tree roots and actually integrate themselves in the tree roots. And then they also extend out into other trees, other plants, into the soil food web, if you will. And then the effects on the fungi are they can transfer material, right? They can provide stuff to the plant roots that it can't get otherwise. They can also transfer material out from the tree if it has excess, and that could be provided to another tree. And of course, then the fungi get glucose from the tree, which is their side of the benefit. So then some of these are species to species, some are species to environment, if you will. And it's really interesting to think about when you talk about it as just sort of the side effect thing, and you talk about the earthworm tunnels, which you mentioned before, the cherry tree McDonough mentions in Cradle to Cradle, the cherry tree drops, tens of thousands of cherries without hope that hardly any will become of new trees, right? But it benefits the birds, it benefits the soil, and can we design systems that are regenerative like that? And of course, beaver dams, etc. And then the industrial ecology would be a similar thing. So there you go. There's a number of details. And so then what you kind of want to do is go to Ask Nature and, for example, search on mutualism. And you're going to get lots of examples. And what I really like about this whole way of looking at it is it's giving us a way to think of how to do things regeneratively, right? So we should look for relationships. We should build things where we both give and we receive, and there's a benefit to the environment. It sounds complicated, but look at all the examples we have of it. So that's my first pass at this. There will be more on this later. And thanks for listening.